ಹಲೋ, ವೆಲ್ಕಮ್ ಟು ಸುಬೇದಾರ್ ಸರ್ಸ್ ಅಕಾಡೆಮಿ. ಇವತ್ತು 10th ಸಿಲೆಬಸ್ ಹೋಗಿಂದು ಅರ್ಥಮೆಟಿಕ್ ಪ್ರೋಗ್ರೆಷನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡತ್ತೀರಿ. ಯಾರು ಇನ್ನೂ ತನ ಸುಬೇದಾರ್ ಸರ್ಸ್ ಅಕಾಡೆಮಿ ಒಳಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿಲ್ಲ, ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ರಿ. ಹಾಗೆ ಚಾಪ್ಟರ್ನ ಎಂಡ್ ತನ ವ್ಯೂ ಮಾಡ್ರಿ. ಓನ್ಲಿ ಫಾರ್ CBSE ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಸ್ಟೇಟ್ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್. ಓಕೆ, it is a very important and easiest topic in this chapter. You have to remember only six formulas. Based on those formulas only we are going to analyze the problem and substitute those given terms and solve the problems. Okay, are you ready? Let's start. Okay, let's start arithmetic progression. Arithmetic progression. What is arithmetic progression? First I will consider some numbers: a plus d, a plus 2d, a plus 3d, and so on, and last term a plus n minus 1 into d. So it is only for exam purpose. Okay, here I am going to start directly the formulas and the some basic of arithmetic progression. If suppose 1, 2, 3, 4, 5, 6, so on up to 10. Here we have 10 numbers. Here the first term is 1. First term is 1. And the difference between these two is again 1. What about third term and second term? The difference between third term and second term, it is also 1. Fourth term and third term, it is also 1. So here the common difference is d. In the arithmetic progression, common difference is denoted by small d, and the first term is denoted by a. See here, a plus d, we are going to get a second term. That is a second term. Again, a plus 2d, third term. A plus 3d, fourth term, and so on, last term. A plus n minus 1 into d. Here a is the first term, n is the number of terms, and d is the common difference. A is the first term, right, and n is the number of terms. D is the common difference, right? Here these are called terms. Here we have 10 numbers, so 10 terms. Here we have n numbers, so n terms. Clear? So important. So then what is the formula for this one? First, ಮೊದಲೇ ಹೇಳಿದೀನಿ ಈ ಚಾಪ್ಟರ್ ಒಳಗೆ 6 ಫಾರ್ಮುಲಾ ಬರ್ತವೆ. 6 formulas. Here we have 6 formulas. First one is an. An is the last term of the given series, right? An is equal to a plus n minus 1 into d. A plus n minus 1 into d, where a is equal to again first term only, and n is equal to number of terms, and d is the common difference. ಇದೇನಾಯ್ತು, ಸ್ಟಾರ್ಟಿಂಗ್ ಏನಾಯ್ತು, ಈ ಫಾರ್ಮುಲಾ ನಾವು ಕೌಂಟಿಂಗ್ ದ ನಂಬರ್ಸ್ ಫ್ರಮ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಟು ಎಂಡ್. What about if end to starting? What about if end to starting? So here an is the last term. And an last term can also be defined as a tn, or else small tn, or else l. ನಿಮಗೆ ಎಕ್ಸಾಮ್ ಒಳಗೆ ಯಾವ್ದು ಬೇಕಾದ ಟರ್ಮ್ ಕೊಡಬಹುದು, an or tn or l. L is the last term. If I am going to write this series from the last, this can also be written as l minus d, l minus 2d, l minus 3d, and so on up to a. Last to first, as we know that a plus n minus 1 is the last term, so this can also be written as an, right, or l or tn. Here I have used l. Okay, l is the last term. L minus d, l minus 2d, l minus 3d, and so on up to a. Now I am going to compare this with this equation. Right? Here first term is A, but here first term is L. Okay? Here L is the first term. And what is the common difference between these two? See here, L minus D minus L. Here plus L minus L get cancelled, we remains with minus D. What about third term and second term? L minus 2D minus L minus D. After removing bracket here we are going to get L minus 2D minus L minus into minus plus D. Here plus L minus L get cancelled. Minus 2D and plus D is again minus D. So the common difference is here minus D when we are going to calculate from the end. Right? So common difference is equal to minus D. Right? Then what is the formula for this one? So AN is equal to L plus N minus 1 into D. Here A is the first term in this equation from the end. This is from the end. Okay. From the end. Here L is the first term and N is the number of terms and D is the common difference. Minus D is the common difference, right, from the end. So this is a one formula and this one is a second formula. Note it down. Okay, ಈಗ ಎರಡು ಫಾರ್ಮುಲಾ ಯಾವ ನೋಡಿದ್ವಿ ನಾವು? ಒಂದನೇದು AN is equal to A plus N minus 1 into D. This is from the beginning, okay, from the starting of the sequence, right? Second one ಏನು ನೋಡಿದ್ವಿ? AN is equal to L plus N minus 1 into minus D. After simplifying this one, this can also be written as L plus into minus is minus N minus 1 into D. This is our second formula. Based on these two formulas, now we will solve some of the problems, right? Okay. Now, first one, find the 10th term of an AP. Example, find the 10th term of an AP. AP means arithmetic progression 2, 7, 12 and so on. Here given is solution. First analyze the problem. What is given? Write it down. Given 2, 7, 12 and so on. Now here A is equal to, what is our first term? 2. What is D? Common difference. 2, 7 minus 2, 5. 12 minus 7, again 5. So common difference is 5. Right? And what is N? Here 10th term. Here 10th term. 10 is the N equal to 10. Here we have to find the 10th term. Right? So N is 10. AN we have to find. So therefore we know that AN is equal to A plus N minus 1 into D. Now substitute the given. So here A is equal to 2. N is equal to 10. D is equal to 5. Now simplify this one. 2 plus 10 minus 1 is 9. 9 5 is 45. So 47 is the 10th term. 47 is the 10th term. Note it down. So next example, which term of an AP 27, 24, 21 and goes up to 0. Now here this sequence somewhere is going to 0. Now we have to find the number of that term. Right? So here given is 27, 24, 21 and so on. Here our first term is 27 and 0 is given here. So the last term is 0. Now here we have to find this number, place of that number. So A is equal to 27. What is the common difference? 24 minus 27 minus 3. 21 minus 24 minus 3. So minus 3 because 24 minus 27. Second term minus first term. Third term minus second term is equal to minus 3. Right? Because here before biggest number we have minus sign. So therefore minus 3. So d is equal to minus 3. Here we have to find the value of n. And also given that last term is 0, that is important. An is equal to 0. Now again I am going to use the same formula. We know that An is equal to a plus n minus 1 into d. Here An is given, right, 0. What is our a here? So 27. Here it is 27 plus n we don't know, so keep it as it is. And d is minus 3, so minus 3. Now remove the bracket. We get 0, 27 plus into minus, minus 3 into n, 3n, minus into minus, plus 1 into 3, 3. So this implies 27 plus 3, 30, minus 3n is equal to 0. Now take this minus 3n to this side. We get, it becomes positive. So 3n is equal to 30. Then n is equal to 3 ones are 3 tens are. So therefore n is equal to 0. So 10th term is going to become 0. In this example, the 10th term will be 0. Right? Right on. Note it down. So next example, determine the AP whose third term is 5 and the 7th term is 9. Here we have to create that sequence, that AP, right? Here the given is a third term and 7th term. So solution here given third term is 5 and 7th term is 9. 7th term is 9. And we know that An is equal to a plus n minus 1 into d, right? So An can also be written as a plus n minus 1 into d. Now a3 can also be written as, here in place of n we have 3, right? So substitute n equal to 3. We get a plus 3 minus 1 into d. So this is equal to a plus 2d. But a3 is given here. What is a3? 5. So I will call this equation number 1. Similarly, we can write a7 also. So a7 can also be written as a7 is equal to a plus 7 minus 1 into d. So a7 is given, that is 9, right? So a plus n minus 1, sorry, 7 minus 1, 6 d. So I will call this equation number 2. Solving these two equations, that is equation 2 minus equation 1, we get, see here, equation 2 is a plus 6d is equal to 9 and equation 1 is a plus 2d is equal to 5. Here the equation is minus, so therefore minus, minus, minus. Here plus a minus a get cancel. 6 minus 2d is 4d is equal to 9 minus 5 is 4. Then d is equal to 1. Here d is equal to 1. Now put d is equal to 1 in equation 1. Equation 1 becomes, either you can substitute in equation 2 also, you are going to get the same value, right? So therefore now here a plus 2d is equal to 5 is the equation number 1. Now I am going to substitute here d is equal to 1. So that is a plus 2 into 1 is equal to 5. A is equal to 5. 2 ones are 2. Now transfer this one to this side. It becomes minus. So a 5 minus 2. Then what is the a value? A is equal to 3. Now here we have to create that AP, determine that AP, right? So here first term is 3 and common difference is 1. Then what is that AP? So therefore required AP. Therefore required AP. First term is 3. Second term a plus d, that is 3 plus 1, 4. 4 plus 1, 5, 6 and so on. This is the required AP. Write it down. So write down next number, next problem. check whether 301 is a term of the list of the numbers 5, 11, 17, 23 and so on. Here the problem is whether we have to check whether this number is lies in this series or in this AP, right? So solution here given is 5, given AP 5, 11, 17, 23 and so on. What is A here? A is equal to 5. What is D? Common difference. So 11 minus 5, 6. 17 minus 11, 6. So common difference is 6. And what is AN? Last term is given, that is 301. I will consider that one as last term. Okay, 301. And what is here we have to find what is the value of N, the term N. If it is satisfied, then 301 lies in this equation, right? So 10th term or 11th term, like this we have to get, right? So we know that again same formula, AN is equal to A plus N minus 1 into D. What is AN? Now substitute the given. AN is 301 is equal to what is A? 5 plus N we don't know. That is only we have to find, right? So what is D here? 6. Now remove the bracket. 5 plus 6 into N, 6N. 6 into 1, 6 is equal to 301. Right? 5 minus 6 minus 1. Take this one to LHS. It becomes plus. So 302 is equal to 6N. Then N is equal to 302, 6 divided by 302 divided by 6. After cancelling this also we are going to get the digit is a fraction. So here we are getting a fraction number. So it is not belongs to that AP. So 301 not lies in this AP. Right? So note it down. Next question. In a flower bed, there are 23 rose plants in the first row and 21 in second row, 19 flower rose plants in third row and so on. And also there are 5 rose plants in the last row. So now we have to find how many rows are there in the flower bed. First analyze the problem and write the AP. Okay. So first solution. Here given is in the first row we have 23. So given 23. Second row here we have 21. Third row 19 and so on up to last 5. So this is an AP. How? Here first term is 23. The common difference is 21 minus 3. 21 minus 23. D is equal to minus 2. 19 minus 21. Again minus 2 and so on. The common difference is minus 2. Right? What is last term? That is AN is equal to 5. Here what we have to find? How many rows? Number of rows. That is N we have to find. So again we know that AN is equal to A plus N minus 1 into D. Now substitute the given. Here AN is 5. A is 23 plus N we don't know. So keep it as it is. D is minus 2. Now simplify. 5 is equal to 23 plus into minus 2 into N, 2N, minus into minus, plus 2 ones are 2. 5 is equal to 23 plus 2, 25, minus 2N. Now transfer this minus 2N to LHS and this 5 to RHS. We get, it becomes positive and 25 minus 5, that is equal to 20. Then N is equal to 20 by 2, so is equal to 10. So therefore How many rows are there in the flower plan? So 10 rows are there. That is there are 10 flower beds. There are 10 number of 10 flower plant beds. There are 10 flower plants. Write it down. So write down next example. For what value of k will k plus 9, 2k minus 1, 2k plus 1 are the consecutive terms of an AP? ಇಲ್ಲಿ 3 term ಕೊಟ್ಟಿದಾರ. Now we have to find the value of k when the value of k comes, whether it is an AP or not. Here they have given that it is when it becomes an AP. Right? So the given terms are here. 2k minus 1. Sorry. First term is k plus 9, 2k minus 1, 2k plus 7. They are given 3 terms. Suppose here we consider one general example, A1, A2, A3 and so on up to AN. This is our AP. Consider it is an AP. What is an AP definition? Common difference is same. So that is A2 minus A1, A3 minus A2, A3 minus A2 and so on. A4 minus A3 and so on. All are equal. So that is denoted by small d. Now here we have 3 terms. The common difference is also same here. If it is an AP. So that is a second term. This is our second term. This is our first term and third term. Right? Second term minus first term. That is 2k minus 1 minus k plus 9. Second term minus first term is equal to third term minus second term. Now simplify this one, you will get the k value. So that is remove the bracket, 2k minus 1 minus k plus into minus minus 9 is equal to 2k plus 7 minus 2k minus into minus plus 1. Here plus 2k minus 2k cancel. And here we remains with 2k minus k, 1k, minus 1 minus 9, minus 10 is equal to 7 plus 1, 8. Now take this 10 to RHS side, we get plus 10. So 10 plus 8 is equal to 18. So that is k value is 18. When the k value is 18, then the given will become an AP. Right on. So now it is the time for a third formula. Okay. Now suppose A, B, C are in AP. Then formula is A is equal to 2B is equal to A plus C. 2B is equal to A plus C. How? So consider here A, B, C are in AP. Right? A is our first term, B is our second term, C is our third term. Right? The common difference between is same. That is B minus A is equal to C minus B. Now take this minus B to this side and minus A to this side. B, this becomes plus B is equal to minus A becomes plus, so A plus B. B plus B is 2B, A plus C, or else this can also be written as B is equal to A plus C divided by 2. So this is the third formula. ಈಗ previous one example ಮಾಡಿದ್ವಲ್ಲ ಅದ್ರಾಗ ಏನಿತ್ತು 3 terms given. So that is k plus 9, 2k plus 7 and 2k minus 1, I think so. 2k minus 1. Right? That is 2k minus 1, 2k plus 7. Here, this is our A, this is our B, and this is our C. Now I am going to apply this formula. Whether we are going to get the k value is same or not. Now we will check that one. So here we know that B is equal to 2B is equal to A plus C. Right? In place of B, here we have 2k minus 1 is equal to, in place of A, k plus 9, in place of C, 2k plus 7. Now simplify. 2 2s are 4k minus 2 is equal to k plus 9 plus 2k plus 7. So 4k minus 2 is equal to k plus 2k 3k, 9 plus 7 16, so plus 16. Now take this minus 2 to this side and plus 3k to this side, LHS. We get 4k minus 3k, 16 plus 2. Again k is equal to 18 only. So you have because method ಮಾಡಬಹುದು. Either you can do this one or else the previous one only. Right on. So next example, show that a minus b whole square, a square plus b square, a plus b whole square are in AP. To show that AP, common difference is same. Right? First we have to show that the common difference between the consecutive numbers is same. Right? So solution here. Here given a minus b whole square, a square plus b square and a plus b whole square. First I will find second term minus third term, second term minus first term, next third term minus second term. If both are same, then it is an AP. If not, it is not an AP. Right? So consider this is our A1, A2, A3. Right? A2 minus A1. That is a square plus b square minus a minus b whole square. A2 minus A1, right, is equal to, I will call this one as a common difference D1. Simplify this one, we get, this is a square plus b square, keep it as it is. A minus b whole square formula, a square minus 2ab plus b square is equal to D1. Here outside is minus, so keep it in bracket as it is. Right? Now remove the bracket. A square plus b square minus a square, minus into minus, plus 2ab, minus into plus, minus b square is equal to D1. Here plus a square minus a square plus b square minus b square, and we remains with D1 is equal to 2ab. I will call this equation number 1. Now I will consider A3 minus A2. Consider D2 is equal to A3 minus A2. What is our A3 here? A plus B whole square. A plus B whole square minus A square minus A square plus B square. A3 minus A2. D2 as it is. Now remove the bracket. We get A plus B whole square formula. A square plus 2ab plus b square. Remove the bracket here. Minus into a square is minus a square. Minus into plus minus b square, b square. Again plus a square minus a square plus b square minus b square cancel. And we remains with here D2 is equal to 2ab. I will call this equation number 2. Now compare equation 1 and 2, equation 2. We know that we have from 1 and 2, we conclude that D1 is equal to D2. If common differences are same, then the given terms are in AP. So therefore, A minus B whole square, A square plus B square, A minus A plus B whole square are in AP. Note it down. So next example, find A and B. So that the numbers A, 7, B, 23 are in AP. So here given sequence AP is A, 7, B and 23. These are the terms of an AP. Now here we have to find the value of A and B. Here we have 4 terms. Suppose consider here general terms A1, A2, A3, A4. 4 terms. The common differences are equal. So that is a common difference D is equal to A2 minus A1, right, equal to A3 minus A2 is equal to A4 minus A3. Right. Now I am going to apply this one only. Here the common differences are equal. So that is a D is equal to, that is a A2 minus A1, 7 minus A. Then only it becomes AP. Yeah? When the common difference satisfy, then it will become AP. So 7 minus A is equal to B minus 7, A3 minus A2 is equal to A4 minus A3. Because in place of A1, A, A2, 7, A3, B, A4, 23. So substitute here. Now these two are equal. Consider. I will consider these two. B minus 7 is equal to 23 minus B. Right? Minus B, transfer this side. So it becomes 2B is equal to minus 7, transfer this side, plus 7. So 23 plus 7 is equal to 2B is equal to 30. 2 ones are 2 15s are. That is B is equal to 15. Right? Now I will consider first 2 terms. Now consider, that is 7 minus A is equal to B minus 7. Now here we have B value, that is 7 minus A is equal to, B value is 15 minus 7, that is 8. 7 minus A is equal to 8. Now transfer A to this side and 8 to this side. We get A is equal to 7 minus 8, that is minus 1. So therefore A is equal to minus 1, B is equal to 15. So this is the required values of A and B. So note it down. So ಇವಷ್ಟು ವಿಡಿಯೋ ಚೆಕ್ ಮಾಡ್ರಿ. ಎನಿ ಡೌಟ್ ಕಮೆಂಟ್ ಮಾಡ್ರಿ ಅಂಡ್ ರಿಮೈನಿಂಗ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಮಾಡೋಣ. ವೇಟ್ ಇದಕ್ಕಿಂತ ಮೊದಲ ಲೈಕ್ ಮಾಡ್ರಿ, ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡ್ರಿ, ಫಾರ್ವರ್ಡ್ ಮಾಡ್ರಿ. ಥ್ಯಾಂಕ್ ಯು.